Saxon Algebra 2, Lesson 110. Greetings, students. We are going to talk today about linear graphing on a line. And it's a little bit weird, but stick with me. Up till now, we have done things like this, right? I mean, just as a simple example, we've dealt with inequalities where you have to do some algebra first before you can graph it, right? We know that we can put a domain on this, right? Could be the reals, could be the integers, could be the positive integers, but we know that this affects how we draw the picture. We know that this also affects how we draw the picture. With this, if it's the reals, then we use arrows. And if it's the integers, which I believe the symbol is a Z, we draw the dots. That's integers. Okay. We know that if there is just this, we do not include the exact value, but if there's this, we do include the exact value. I'll remind you of those rules as we graph. It's hard to be clear on that as we are just talking with words. And we know that we can do algebra to these. What we're going to do is extend that algebra today to quadratic expressions. We can graph things that are actually quadratics. The first one, John's going to help us out and give us a little bit of a head start, but the second one will get the full-blown challenge. There are only 2 examples in this lesson, and there's a second part to this lesson. 112 is the less than quadratic inequalities, which are a little bit different. Graph on a number line, and then this is what John shows us. This is what I mean. We're graphing not just a simple expression like this, but we're graphing what is actually a quadratic expression. It's going to be, there's going to be an x squared in it if we multiply that together. Here's how we graph it. The first thing we do is look here. We know that when these 2 things are multiplied together, we want them to be greater than 0. That means we want them to be a positive number, right? What are the 2 ways we can multiply things together and make them be positive? Well, and here are the 2 things that we're multiplying, right? If this number is positive and this number is positive, then that will be greater than 0. So I'm going to make a little chart over here that shows positive, positive. That covers the scenario where both of these values will end up being positive, and then that will give us the positive answer that we want. But there's another way to get a positive number, which is what we want, and that is by multiplying 2 minuses together, right? If this is a negative number and this is a negative number, when we multiply them, they will be greater than 0. So there are 2 ways that we can make this become a positive number. Now that we've set 2 positives, 2 negatives, right? Now that we've set that up, we're not going to look at this inequality anymore. We're now looking at these charts that we've made. If we want the first of our terms to be positive, then we write x plus 2 needs to be greater than 0. Right? If this is going to be a positive number, then it needs to be greater than 0. If this is going to also be a positive number, then this also needs to be greater than 0. Make sense? I used this inequality to set up my 2 charts, And now I'm using what's in the charts to help me figure out how to write these simpler inequalities that will allow me to go ahead and solve the problem. Now, remember that both of these must be true in order for the answer to be positive, right? Because we said positive and positive, both of these things must be true. Now let's look at this side before we're going to do a little simple algebra on that, but let's set up this side. In order for this to be positive, these two quantities must both be negative. So in this case, x plus 2 must be less than 0, and also x minus 3 must be less than 0. Make sense? So we have used these indicators to help us set up these 4 smaller inequalities that will lead us to the correct answer. Now we're going to just do the algebra on these, change sides, change signs. So I know this is going to be x is greater than minus 2 and x is greater than positive 3. And this is x is less than negative 2 and x is less than positive 3. Okay, we don't have to show that intermediate step of swimming the fish. If you're comfortable with doing this, by all means, go ahead and do it. Okay, so now we've come down to the next level. We've done the algebra. Now what we're going to do is graph the solution of each of these independently. And what we can see over here is that this says x has to be greater than negative 2. So here's negative 2. Remember, I circle this because I do not want to include the exact value. So I circle it, and I know that all of these solutions will make this one come true. But I also need to make this one come true, so I better graph that. Here's positive 3. Here's the circle of that. And then I'm going to go up here and draw that arrow. Okay? So there are our 2 solutions. However, the values in here are not going to help me because it will make this one true, but numbers down here will not make this one come true. They will not be greater than 0. Then I would have a negative number over here, and the whole thing would be screwed up. So I need the solutions where both of my inequalities come true, and that's the place where the 2 areas overlap on the graph. Okay, so this is a picture of all the solutions that will give me 2 positive numbers up here, and that will make my inequality come true. Now we're going to make a map of all the negative numbers. So let's draw another number line. And here we have negative 2 again. Again, we're circling because there's no equal sign under there, so we don't include the exact value. And all of these values will make this inequality negative, which is what we want. But I have to make sure that both are negative. So let's graph this one. Here's my positive 3, and I circle that, and then this is all the values going this way. Again, these values here don't do me any good because they make one of these come true, but not both. And I have to get both to come true in order to get my positive outcome that I want. So these are the solutions that will give me 2 negative values and therefore make that come true. So you can see that when we have a greater than inequality situation, which is what this is, we're going to get 2 partial answers, and then our final step is to put them on one number line. This goes from negative 2 down, and this goes from 3 up. And that is how we can write the final answer. For the sake of aesthetic, if you like, these lines are important because they show where the 2 partial solutions overlap. Some students like to just bring those forward. I do too. I think it looks nice so that we can see it there. All right. By the way, this is similar to what John does in the book, but I add a lot of flourishes. So my solutions look a little different than John's. All right. So that means that all of these solutions will make this quadratic inequality come true. That's what we found there. Beautiful, right? We're going to do one more. The only twinkly twist, let me show you. The only little twist is that this time, John is going to give us the quadratic in its standard form, even a mixed up standard form. And he's going to switch out the domain to the integers. All right, so we'll deal with that at the end. What we have to deal with to start, let's see, I forgot the x, which is right here. What we have to do first is we have to get this all on one side in the proper order, and then we have to factor it. Okay, but that's not a big deal. So let's bring the 3 over. It will be x squared minus 2x. That stays the same. He changes sides, so he changes signs. He becomes minus 3 is greater than or equal to 0. Okay, good. Now it's in perfect standard form. Now we want to factor it. And the good news is it's fairly straightforward to factor. Two numbers that multiply to this and add to that. And it would be, let's see, it would be minus 3 and positive 1. Make sense? They multiply to that and they add to that. Okay, now this is where the last problem began. So now everything else will be the same. So we stop and think. If we want these two things to multiply together and be greater than 0, there's two ways we can do that. A positive positive or a negative negative, right? Just like last time. And by the way, every time you have a greater than quadratic inequality, this will always be the pattern. If you can keep a secret, when we do less than inequalities, when this is going the other direction, these columns will change. We'll get to that in lesson 112. But in greater than inequalities, this will be always the way we do it. Two positives, two negatives. Okay? So now we forget about this and we put our attention on this. If I want the value of both of these inequalities to be positive, then I write x minus 3 is greater than equal to 0 and x plus 1 greater than equal to 0. Side note, if your original inequality has the equal sign, then you include it. If your original inequality doesn't, like in the last problem, then you just leave it off. So you don't have to think about that. Just use the same style of inequality throughout your problem. Okay, so I just set these up so that this will create a positive number and this will create a positive number. That'll give me two positives, and that means it'll be greater than 0 or equal to. Now I need to set these up as two negatives. X minus 3 has to be less than or equal to 0. That'll make a negative number. And x plus 1 less than or equal to 0. That will make a negative number. Remember, we use this one to set up the columns, the column headings. And then we use these values to set up our individual inequalities. Okay, now we're ready to do the algebra. Super easy. Oh, this is minus 1. And this is x is less than or equal to 3. And x is less than or equal to minus 1. Good, right? So now we are ready to graph each of these individually. X is greater than or equal to 3. And this time we're including the exact value. X is greater than or equal to negative 1, including that value. Here is where they overlap. 3 is included in the overlap, right? Because we are willing to include that. And now we'll graph this way. X is less than 3 or equal to. And then x is less than negative 1, so there's another value. And here's where we have our overlap. So now when we go to draw our combined solutions, all of these numbers will work. They'll make this inequality come true. All of these numbers will work, so we can write it on one single number line, and we want to include these values, and positive 3. That. Oh, my bad, my bad, my bad. You know what I did wrong? I did not obey the domain. This is the solution for real numbers, but that's not what we want. So let's draw a big box around this and put a line through it. That's not right. We have to do it again for integers. X is greater than or equal to 3. Okay, so what we're going to need is a few more numbers on our line, aren't we? And let's do this. Let's put 0. I think 0 should go there. We'll put 0 there. 1, 2, 3. And we might want another one. 1, 2, 3, 4. And then the negatives. There. Okay, so now these are the two number lines for us to graph these separately. X is greater than or equal to 3. So there's that. And then X is greater than or equal to negative 1. I'm going to put those up above. And we can see that the overlap is here, right? From 3 up. And we can see, look, it is the very same as what we graphed for the reals. We're just graphing integer style, right? With the dots instead of the arrows. Okay, let's do the same thing for this side. X is less than 3. Whoa, that's going to be a lot, isn't it? But X also has to be less than or equal to negative 1. So here's that solution. And again, we want the overlap. So now we can graph it on one big picture. And we're going to go zero, 1, 2, 3, 4. We can put in one more. We'll put in 5. And I'll say a word in a minute about how I chose these numbers. We want to go from 3 up, and we want to go from negative 1 down. Especially with integers, it's important to draw a number line that shows not only the original point, like we want X to go up from 3, but a couple more to show the movement of your solutions. There's no way to put an arrow on it, and it's very disappointing. But by showing a couple, we can give a sense of, okay, the solutions go that way. And then the same thing down here. I want to have a couple. 3 isn't necessary, or I mean 3 is the number I shoot for. This one had a 4th point. That's nice, but if you can graph 3 points, make your number line big enough so you can graph 3 points to show, oh look, they're going that way. Then that will give you a nice sense of explanation in your solution. Guess what? Now I got the right answer. This isn't wrong, it's just, well, it's wrong, it's the wrong domain, right? The calculations were correct, but I graphed the wrong domain, and so I fixed it. Make sense? Yay, lesson 110 is done. Again, we're gonna come back to this in lesson 112 and deal with less than inequalities. This is greater than, and it always makes the pattern of we want 2 positives or we want 2 minuses. Yay. Okay, thank you, goodbye.